Hello, Sudwood here, and welcome to part 3 of my Redstone adder-subtractor tutorial. From the last part, I have added some things. I added just this one line of torches here, so that because our adders can only count up to 15, or 1111, there's this one carry out over here that if we just left it there, wouldn't display anything and we wouldn't know if it was over 15. So I just brought it along up here and brought it up to display of it. I've also finished all the decoders, and that was a long job. Took a couple hours at least. Just get all the wiring right and test them all, make sure it all works. So let's test it. So 4 plus 8, and you get and you get 12. If you add one more to it, you get 13. Oh, and I know last video I had the line on the other side looked like an E. When I built that, it was around 2 in the morning, and I was really tired, so I hope you can forgive me. And if you add 2 more to that, you get 15. There you go. If you add 1 more, let's see. Yep, it's over 15. So we look over here, and that should be lighting up. What did I do wrong? Let's try it again. Okay, what if we switch all of these down? Because 1 plus 2 is 3, plus 4 is 7, plus 8 is 15. So we should get 15 again. Or maybe not. Nope. Oh yeah, I see what's wrong. It can't be all on the same side. So if we have y equals 16, if we have 12 plus 4, we should get 16. We get 1. And why is that? It was working just a minute ago. Let's see, we have, what do we have? Do we have perfect? Yes, we have the one over here turn. Wait, what? Why is this one turn up? Okay, so we have, there we go. Turn this one off. Now that equals 16, because we have the 4 over here, and 8 and the 4 over here. So those 2 are off, and that one's still this one on. Doesn't seem to be working for some reason. Okay. This is why you always have to check and make sure everything works. I did a few checks, but not 100%. Okay, 1 plus 1 should equal 2, and 3 plus 3 should equal 6, and 7 plus 7 should equal 14. Yeah, 8, 4, and 2, 13. Oh yeah, 14, there we go. So if we add 8 to it, what happens? Okay, this should count as an extra 8. Push this over. Why is it not activating that? I don't understand. Okay, so if we activate the other 8, it was just working perfectly. Now let's see. We have this one, push there. Whatever. Let's try adding 8 and 8 this time. It does work, it's just not working right now. Okay, 8 plus 8, you get 16, goes up there, over, the line turns on. There we go, the line turned on. Finally. Anyway, now as you can see, we have something that adds, but we want an adder and subtractor. To do that, we're going to have to subtract using binary, because that's how all our inputs are taken down and converted into their binary equivalent, which is then used in an operation and then turned back into a numerical number and then to a 7-segment. So I'm gonna set up a display in another world to show how we're gonna be doing the subtraction. I'll be right back. Okay, and I'm back. I built a mock-up of our adders. First, I need to explain something. Binary works, as I've explained before. You can have either a 1 or a 0. And when you're adding, if you add a 1 and a 1, that needs to get carried over, so it becomes this one over here and 0 over here. 1, 0 or 2. Subtracting in binary runs with something called 2's complement, which is basically this. Say you have okay, so you have 3, and then you're subtracting 2. If you were adding, this would become a 1, and this over here would become a 2, making 5. However, with 2's complement, you have to get this, you take, oh yeah, okay, so for 2's complement, first thing you do is you add 1 more to the first number. So this is 3, add 1 more and make it 4. There we go, 1 0 0. Then you take the second number, the one you're subtracting from the first number, and this one was, for instance, 1 0. You have to invert all the numbers. So for instance, hold on 1 second. Okay, so because this is 1 0 0 1 1, it now becomes 1 0 1, and then you add them together. So 0 plus 1 equals 1, 0 plus 0 equals 0, 1 plus 1 equals 1 0. Okay, so you end up, so we originally started with 3 minus 2. We originally start with this. Now we have 4 plus 5 equals 9. You're probably wondering, how does this equal subtraction? Well, with 2's complement, you just completely ignore the highest number. So your answer is 1. 3 minus 2 equals 1. Now comes the difficult part. Because we have to invert, we're making a calculator has an option for subtraction. Okay, so we have to make it so that if we flip the lever, power comes into here and makes it so that B is not B, or B is the opposite of B. So to do that, we use what is called an XOR gate, which recently a piston version has come out, which is much smaller. This is how you build it. You go here. First you provide power to here and to here. Here's where the B comes in. This line. And this is the one that makes it not B. So if this one's powered, B is not B. If it's not powered, B equals B. Next you put a redstone torch here, a piston here, block here, 2 repeaters here, and the output right here. So there's no output. B currently has no power. However, if we do give B power, B is B. However, if this is turned on, the opposite unit, we get B is off, so it's not B or on. If B is on, not B is off. Okay, and you have to do this for every single B input. So let's just build one over here. And this. Okay. One block here. Repeaters here. It's rather simple. The older XOR designs that required that didn't have pistons were about 5 by 5 or 6 by 6. This is just a 3 by 3 or 5 by 3 if you count the inputs and outputs. Okay, so we have that. So we have those two hooked up, and two more. And hook up this one, which goes here. It's rather simple, and you can easily build it in just a couple seconds. Which is, I think, the best part about this. It's not really complicated or anything. So, it's easy to remember. Okay, we have that hooked up. Now, this and this. Here and here. This last one, we can just go here, here. Piston. And these are all sticky pistons. By the way, you don't use any regular pistons in this one. Okay, up to here, and inputs. Okay, we have that all hooked up. Can get rid of this. Okay, say we want this lever right here to turn on subtraction. What we'd have to do is wire this to all these inputs over here on to turn B, not B. There you go. There's that one. This one. And this last one. Okay, we have all the enablers to make B not B if we need to. And because 2's complement requires that you invert B, the second number, the one you're subtracting from the first number, this is, we have one part of the subtraction done. Now, you also need to add 1 to you have to add 1 to the carry in over here. As you remember from the last video, this right here is the carry out, and this part right here is the carry in. If I were to add 1 right here, I would have 1 as an output because it's 0 plus 0 plus 0 plus 0 plus this 1 right here. So, I have 1 as an output because I have 1 carried in. And just let me get some more redstone. There we go. So we want our switch over here to turn up, to add 1 also. So if we just bring some wire this way. There we go. Now, just wire this up. Make sure your wires reach all the way. Yep. There you go. And here we go. So we now have a subtraction switch. Okay, first let's check and make sure addition works. So let's add 1 plus 0. We get 1. Add another 1. And we get 2. Okay. Now if we switch on subtraction, this one right here, pretty sure has to be a repeater to get it to work right. Okay, let's try. What is this? This is 2 minus 1. We get 1. So that's working. 2 minus 0, we get 2. 8. Let's try 8 minus 4. Should get 4. Yep. Now, if we take 2 minus 2 minus 4, we get a wrong answer. Let me check and see what I did wrong. So we have 2. Let's have, okay. Start simpler. 2. What? No, that's 1. 1 minus 2. Okay. We get 15, which is wrong. Okay. Seems to be a problem. Okay, see if we subtract 1 minus 3, what do we get? We get 4 plus 2, 6. 1 minus 3 does not equal 6. Okay, I will be back once I figure out what the problem is. So, see ya in a couple minutes. Okay, I'm back. Finally figured out what was wrong with my subtraction thing, and I realized I had forgotten how to interpret the answer for 2's complement. Because of this, I'll have to rethink how I'm going to do the 7-segment decoder for subtraction, so that'll probably be in another episode. However, I am kind of glad that I'm making these mistakes, as it shows mistakes other people can run into if I'd just done it perfectly every time. Someone might make a mistake and not realize where they are, so it's kind of helpful. Anyway, right now we have 2 minus 4, and we get 1, 1, 1, 0. So it's 8 plus 4, 12 plus 2 is 16. So, how is that helpful? Well, if you're trying to take a negative number from 2's complement, you have to do 2 things. First, you have to subtract 1 from that. So if you're trying to, okay, we have this. This is what we have, and we want to take this from it. Now, to do this, excuse me, it's getting really late, around 2:15ish. Anyway, what we need to do is take 1 from that, and just like in regular subtraction, we can't take 1 from 0, so we have to borrow 1 from here. So now, that was a 2 or a 1, 0. So now in this column we have a 1 and a 0, or 2. So if we take a 1 from 2, we end up with 1. So now we have 1, 1, 0, 1. The second part is we have to invert the answer. So we have to invert it again. There we go, we get 2. Basically, when you have a negative number, you have to undo all the subtraction work you just did to get your answer. And that's going to be all for tonight. Probably upload this tomorrow. The next part should be up in a day or so. This is Sudwood signing off. See ya.